All right, friends, we're talking about Math 105, Section 4.3, exponential graphs, and what we're going to focus on here are constants and how to think about our constants in some functions. So if I was going to start out with a problem like this, and I think this is really our classic, let's have AB to the t. For our first one, let's call that one y1, and y2 will be CD to the t. I think we can get our heads wrapped around a couple of things really well here. Well, certainly, A, B, C, and D are all greater than 0. Well, how do we know that A and B are greater, or A and C are greater than 0? Well, they're both above the horizontal axis, that t-axis there, and we know that we have exponential growth. And so now, can we do anything to order these? And I think we can certainly say that A is less than C. A is our initial value, and C is our initial value there. Can I order anything else? And I think the answer here is yes, because when I started with a smaller initial value and I began to grow faster and faster and faster, we knew that this growth factor, B, is certainly greater than that of D. And maybe what I could do as well, if I wanted to say these things, and I'm going to use these exact same constants here, if I picked some new value, 0k, and I made the two functions, a, or k, b to the t, versus k d to the t, we would know that both of these would have exponential growth, but then d is less than b. They're emanating from the same point, and they're both going upwards, but b is going faster. So other than that, I think all bets are off. And so we don't really know how A and D or A and C work together because I don't have any scale here. If I put 1 right there, then we would clearly know all of the orders. Then A would be less than C, which would be less than D, which would be less than B. That's if we have 1 right in here. But if I don't know where 1 is, suppose 1 would be right there, we have no way of telling. We know that B and D are greater than 1, but because there's no scale here, we can't tell which of these is related to B or D in any sense of the word. Let's do one more example. And this example is much trickier for us to think about. And what I'm going to remind us of here is if I started out at some point here, and let's call that k again, 0k, and I did something like this, kb to the t, and kd to the t, and now I'm going to have a different point here. And what's interesting is I increase my initial value. These curves, they're not necessarily going to be parallel to each other. I'll call this one, we'll say 0 and then m, d to the t. And what's interesting is that when I have an initial value that's greater, it's going to make the curve go steeper because I'm going to be taking that and multiplying it over and over. The takeaway here is, if I have two curves that look like this, I don't even care about what the a value is. We'll say we have ab to the t, cd to the t in this case. We have no way of telling whether b is greater than d or d is greater than b. And the reason for that is we have our initial values, and the initial values, they offset. They make the curve look steeper the higher up we go. And you can see this on Desmos as well. Enter in 1.5 as your growth factor, and then start out with a growth factor of 10 and a growth factor of 20 to the t. And you'll see that these two are not parallel to one another, and that even though we have the exact same growth factor, we can't tell which one is bigger than the other, just the way things are. In fact, in this case, they're going to be exactly the same. So I think the bottom line here is to make no bets that you can't cash. If I have an initial value and it grows faster than another initial value, then we know certainly that that growth factor is greater than the other one. But in this case, like I said, there's no way. The only thing I can definitively say here is that A is by all means greater than C. I could also say that B is and D are both greater than 1. I think the exact same things are true when we talk about exponential decay. If I have two exponential decays and they cross one another, I can certainly say that this one is shrinking faster than this one, that the growth factor here is smaller than the growth factor there. But if I have two exponential decays and they're both decaying, I have no real way of telling which one is smaller than the other, for the exact same reason that we can't tell which one is bigger for that problem.